electric potential due to an electric dipole. So let's understand the basic concepts of electric dipole. So electric dipole, let's recall from first chapter. An electric dipole is nothing but it's a pair of charges, equal and opposite charges. So let me just take it as positive charge. Let me place it here plus q, and let's take a negative charge here minus q. Okay, this is our positive and negative charge. Now you can place it here. This is our location. Let's call it as A, and let's call it as option here B. Okay. Now this is the separation between A and B. Okay, separated by any distance 2a, as we have taken in the first chapter. The separation between A and B is 2a. Why we take it as 2a? So that when we split it from the middle, okay, when we take the distance, measure the distance from the midpoint, okay, this gap will become A and the other gap will also become A. That's why we take it as 2a. If you remember from first chapter, let's call it as point P, the midpoint of the electric dipole. Okay, and let's say we are finding the potential due to this electric dipole at any point Q, anywhere. Now be very careful. In the first chapter, we took this point at perpendicular bisector, right? Or axial point or equatorial, and we were finding electric field. In this chapter, we are finding it at the any point, neither on the equatorial plane nor in the axial plane. It is at any point inclined at any angle theta from the center of the dipole. So let's draw a line here, and this angle is over here. This angle is theta, correct? And this point Q from the first charge, the first positive charge, it is at a distance of R1, let's say. Okay, so this is our R1. And from the second charge, this point Q is at a distance of R2. And from the center of the dipole, this PQ is nothing but R. If this is theta, what will be this angle? 180 minus theta, right? So this is 180 minus theta over here. Let me repeat again. We have an electric dipole. Okay, the separation between the two charges is 2a. We are finding the potential at any point Q situated at R from the center of the dipole. From the first charge, it is at the distance R1. From the second charge, it is at the distance R2. Clear? So let's figure out the potential. Now, first of all, what will be the potential at any point Q due to the charge placed at A? It will be 1 by 4 pi epsilon naught, the charge which is placed at A, which is Q, upon the separation AQ, correct? And what is AQ? AQ is nothing but Q upon 4 pi epsilon naught R1. This is our potential at Q due to A, equation number 1, correct? Now let's move ahead and find the potential at any point Q due to our second charge which is placed at B. So that will be minus Q upon 4 pi epsilon naught R2, correct? Where the separation is BQ. So do we have to take the negative sign? Yes, you have to take the negative sign because it's a scalar quantity. Potential is a scalar quantity. So what will be the net potential at any point Q due to this electric dipole? It will be VQA plus VQB, correct? Okay. Now what we will do? We will substitute these values. So on substituting, this will be giving us what? Q upon 4 pi epsilon naught R1 minus Q upon 4 pi epsilon naught R2 from 1 and 2. This will be your potential at Q. Now let's take common out. What's the common between the both? Common between both is Q by 4 pi epsilon naught, and this will be 1 by R1 minus 1 by R2. This is our potential at Q due to both the charges. Now we have to figure out the value of 1 by R1 and 1 by R2. This is our equation 3. Once you figure out the value of 1 by R1 and 1 by R2, you can substitute here and we will get the final expression, right? So let's keep the diagram as it is in, okay, here, and let's write the expression. Okay, so if you look at the triangle, let's take the triangle, first one. The first triangle is triangle APQ. I hope you can locate the triangle APQ, which is this one. This is our triangle APQ. And here, if this is angle theta, which side is opposite to angle theta? Side opposite to angle theta is AQ, correct? So according to law of cosines for a triangle, law of cosine says r1 square, which is this square, this side square, will be equals to r square plus a square minus 2ar cos of angle theta. Let me repeat again. According to law of cosine, this is there in maths. So it says if you have a triangle and if it is not a perfectly 90-degree or it's not a right angle triangle, then the angle, if you are given with the three sides and one angle, this will be the equation that triangle will satisfy. Okay, you can simply take it cos theta. If theta is 90-degree, it will become right angle triangle, and this whole equation cos 90 will become 0, and this equation will satisfy as Pythagoras theorem. Clear? So this is our triangle from triangle APQ. Let's take the lower triangle. So from the triangle B, P and Q. So let me call this equation as equation number 4. And from equation, let's move to BPQ. It's R2. And this time R2 is the hypotenuse, you can see R2 square, and angle opposite to that is 180 minus theta. Be very careful with that. So it will become R square plus A square minus 2AR cos of, what is the angle? 180 minus theta. Now cos 180 minus theta from trigonometry, what we have? Sir, we have cos 180 minus theta is minus cos theta from 11th standard. So R2 square will be equal to R square plus A square plus 2AR cos of angle theta. But the question is, sir, why we are doing this? Okay, just to figure out our R1, 1 by R1 and 1 by R2. Okay, let's simplify it further. So let's take the equation number 4. So let me just write this equation number 4. Let me just copy paste it over here. So let me just copy it. Okay, so let me just copy this equation and let's go on the other side. And let's write it over here so that we can simplify it further. So let's start from here. This is our equation, correct? So let's simplify it. Then we will come back to our equation number 3. So here, if I take r square common, I will be left with 1 plus a square by r square minus 2a upon r cos of angle theta. Correct? Sir, how you did that? Let's re-multiply this r square back to the bracket. So r square into 1. Sir, r square, we will get the first term. R square into the second term. R square and R square cancels. You left with a square. You will get the second term. And R square into the third term. R and R square cancels out. You left with 2AR cos theta. Clear? So I simply took it common out. Okay. Now since A is very, very small compared to R, so hence A square will be very, very small than R square. So A square by R square will be negligible. It will be negligible. If it is negligible, we can ignore this term. Which term? Let me make a small box around it. This term will be ignored. Why it is ignored? Because of very small value. So R1 square will be equals to R square. And inside the bracket, we left with 1 minus 2A whole divided by R cos theta. Correct? Now let's reciprocate both the terms. On reciprocation, 1 by, let's write it as 1 by R1 square. This will be 1 by R square. And reciprocating this whole term, since it's not a complete here fraction, let's put a power of minus 1. Correct? Okay. Putting here power minus 1. Okay. That is reciprocation. Now take the root on both the sides. So it will be 1 by R1. That will be equals to 1 by R because of square root. And here the power will go to power half. We know square root is nothing but power half. Correct? So that will become minus half. And due to this minus half, now whenever you have a negative power, listen very carefully. If you have a negative power, you can take it in front of the smaller term. That is the binomial expansion of that. So you don't have to do what will be the complete binomial expansion. Just focus on this initial part. So you can simply take this minus half in front of this smaller term. Which is smaller term? Because this is smaller term, smaller than 1, you can see. Okay. So length can never be negative. So this will become 1 and minus minus plus 1 by 2, and the second term as it is 2A upon R cos theta. So we got our value of R1. 1 by R1 equals to 1 by R into 1 plus A by R cos of angle theta. I hope this is clear. Okay. Let me make a straight line over here. Okay. Here. So this is our 1 by R1. And from where we started from this purple equation, R1 square equals to R square plus A square minus 2AR cos theta, and we got this, right? Now, if you see the equation number 4 and 5, there is a very slight difference between equation 4 and 5. All the terms are similar. R square is same as here R square, here A square is similar to A square, this A square is same to A square. Minus 2AR and only plus 2AR. So you have only the sign change, minus and plus. So if there is a slight sign change, then you can directly write without solving. If you want, you can solve it in a similar way, and you can write it as 1 by R2. That will become 1 by R. And instead of plus here, it will be minus because of the sign difference. So this is our equation 6 and this is our equation 7. Once you got our equation 6 and 7, let's put it back to our equation number 3. Clear? So let's put it in equation 3, equation 6 and 7. So let me write here from equation 3, 6 and 7. Potential V Q, the potential at any point Q will be Q by 4 pi epsilon naught 1 by R1. Now what's 1 by R1 from equation number 6? It's 1 by R into 1 plus A by R cos theta, correct? Minus, what's 1 by R2? Minus 1 by R, 1 minus A by R cos of angle theta. Now let's simplify to get the final result. So potential at any point Q of the dipole will be Q by 4 pi epsilon naught. Let's expand it. 1 by R plus A by R cos theta, R square cos theta. Be very careful with the multiplication. Minus 1 by R and minus plus A by R square cos theta. Now let's cancel out the terms which are getting cancelled, 1 by R and 1 by R. And potential at Q will be equals to Q by 4 pi epsilon naught and A cos theta by R square and A cos theta by R square, 2A cos theta by R square. Let's now multiply it. Okay, so on multiplication, this 2AQ will become how much? Let's do it here. So potential VQ will be equals to 2A and Q. 2AQ is dipole moment. So P cos theta upon R square. So if you put theta as 90 degree, that is along the equatorial plane. At equatorial plane, theta is 90 degree. The potential will become 0 at that point due to the electric dipole. And here it is 4 pi epsilon naught. Done.